speakerphone, yeah, turn me up. Got them scared like they're seeing ghosts. Cause be it bars or guitars, man, I be them both. I hear them ask random impulses, he involved. There's no denying I'm on fire, you can see the smoke. Yeah, turn me up till it's sky high. No longer the shy type. Rhyme on the mic, but I listen to the white stripes. Started out in grime, but they didn't get my vibe right.
How's it going, everybody? Today we're going to be talking about impulse. Now, impulse is the change in momentum. So we talked about momentum in the last video, so today we're going to talk about the change in momentum. Now, the change in momentum takes both force and time. So the force will change velocity if an object is either speeding up or slowing down. Now, that is the way we say that is the net external force, which is F, applied to an object for a time interval, which is the change in time, will cause a change in the object's momentum equal to the products of the force and time interval. Now, what all that means is just this that we have right here. J. Now, what does J stand for?
J stands for impulse.
Impulse.
Not
okay.
joules. Impulse.
Now, how do we measure impulse?
Well, like we said, it's a change in momentum. Remember, guys, that force causes motion. And that could be either a change in the object's direction, the change in its velocity, as in like its speed. It could be speeding up or slowing down. So an impulse is equal to, it's a force applied over a change in time, or it's the mass times the change in velocity. And the units for impulse are Newton seconds.
All right, so Newton times second. That's how we measure that. Then we equals a change in force. We all know that force is measured in newtons. Sorry, I'm trying to write this that way y'all can see this. Time, how do we measure time?
In seconds.
Seconds, perfect. All right, let's see. Momentum, now that seems something that we talked about last time. I can't remember what that one was. How do we measure?
Oh, kilogram meters per second.
Okay, so I'll go ahead and put a line here for momentum. And that is kilograms times meters per second. And we know that mass, M is mass, and that equals, and that's kg, and then we know the velocity is meters per second. Now, a small force acting for a long time can produce the same change as a large force acting on a force for a short time. We have things like golf or baseball, and that the follow-through in the swing is important, and coaches harp about that all the time, as that the longer the bat or the club is in contact with the ball, the greater change the momentum will be. So the more time force is applied, the greater actual change that's going to happen.
So the greater the impulse.
Right, so greater impulse. Thank you. A 2,500 kilogram car traveling north is slowed down uniformly from an initial velocity of 20 meters per second by a 6,250 Newton braking force acting opposite in the car's motion. Use the impulse momentum theorem to answer the following questions. So let's go ahead and take a look at both of these questions, and we're going to work on A. So A says, what is the car's velocity after 2.5 seconds? And B says, how long does it take the car to come to a complete stop? So let's go ahead and take a look at A real quick. A says, what is the car's velocity after 2.5 seconds? So it gives us the time. Gives us the time, so T equals 2.5. What else does it give us?
We know the mass of the car.
Mass of the car is equal to
2,500 kilograms.
2,500, which is right here. All right, do we have, what else do we have?
We have initial velocity of 20 meters per second.
Okay.
And the braking force, that's that big capital F, is 6,250 newtons.
So if it's braking and it's going opposite the car's motion, is it going to be positive or negative?
Negative.
All right.
Working opposite the motion. And that's it. So we want to know the final velocity.
Right, so
That's what's missing.
we know that we have time, we have force, we have the mass, and we have our initial velocity. So we're going to figure out what parts of the theorem that we're going to use. What part of this equation are we going to use?
Well, we know we're going to use the big F and the change in time part. That's going to go on one side of the equal sign.
What else do we have?
And then the other side will be the mass times final velocity. The final velocity being what we're looking for, minus mass times the initial velocity. Those are the only parts of the formula that we need.
Okay, so we can go ahead and plug some of these in, right?
Right.
So we have a negative 6,250, and we multiply it by our time.
Right.
So multiply it by 2.5 equals mass times your final velocity. So mass is 2,500.
Yep. Times VF, because we don't know it yet.
Subtract our mass, which is 2,500, multiplied by our initial velocity, which is
20.
20. Okay, so we're going to go ahead and get our knowns out of the way. So we're going to go ahead and multiply these two together and multiply these two together. That way we can go ahead and get whole numbers opposed to just broken up numbers. So what is negative 6,250 times 2.5?
That is negative 15,625.
Okay, and that's going to equal to 2,500 times your velocity final.
Mm-hmm.
And what was 2,500 times 20?
That comes out to 50,000.
Okay, so we're going to minus 50,000. So what is the next thing that we want to do here?
We want to start getting VF by itself. So we're going to add that 50,000 to the other side.
So add on both sides.
That's our first step.
And these will cancel out. So what is negative 15,625 plus 50,000?
That would be 34,375.
And that's still going to equal 2,500 VF, right?
Mm-hmm.
So what's the next step we want to do?
We want to divide that 2,500 over to get VF by itself.
Why would we divide opposed to adding like we did before?
Well, because the 2,500 and the VF are multiplied together. So there's nothing there to add or subtract.
Okay, so divide each side by 2,500, correct?
Mm-hmm.
So this will cancel out. And then we have 34,375 divided by 2,500. What does that leave us with?
13.75 is equal to VF. It's some good algebra.
That is. Awesome. And that is going to be in meters per second.
Mm-hmm.
Okay, so let's take a look at B real quick. I'm going to go ahead and erase some of the rest of the stuff. That way we can have something to work with.
Some space.
Alright, I'll go ahead and leave that up there. That way y'all can write that out. Now that one says, how long does it take for a car to come to a complete stop? So what does that change for us then?
Well, this final velocity that we just calculated is going to become our initial velocity, because this is where we're working from now. The initial velocity is now 13.75 meters per second, and our final velocity is going to be 0, which is at rest. And we're looking for time.
And our initial velocity was 13.75?
Yeah.
Are we still going to use the same parts of the formula like we had before?
Yeah, the same parts of the formula.
Okay, so we're going to have force times time. So force was, again, negative 6,250. And you multiply that by time, which was 2.5?
No, we don't know that yet. We're looking for
Okay,
it.
right. We're looking for time. So how long does it take? So for here,
T is the variable we're trying to get by itself.
right, multiplied by T equals mass, which was 2,500,
Yeah, that hasn't changed.
multiplied by our final velocity, which was 0,
Mhm.
minus 2,500, multiplied by our initial velocity, which was, again, 13.75. So now that y'all have that written down, I'll go ahead and erase this. So we're just going to plug everything in. So what's 2,500 times 0?
0.
And 2,500 times 13.75?
That would be 34,375.
So we're still looking for T. So I'm going to go ahead and write this up here where it says, just rewrite it out with our new variable. So negative 6,250 equals, well, 0. 0 is not going to do anything for us, so we can just go ahead and cross that out.
Yeah.
A negative, because we're still using this negative sign right here, all these right here, negative 34,375. Oh, sorry, I
Times
forgot
T.
to put
Yeah.
I forgot to put the t in there. Whoops. So that came up here. Whoops. Equals. Alright, there you go. Now what do we need to do now?
Let's divide over that negative 6,250.
So we're going to go from this side to the other side, correct?
Yeah.
So negative 6,250 will cancel out there. So 6,250. What does that leave us with?
That leaves us with a positive 5.5 seconds.
Right, because we have a negative here. And
Yeah.
we have a negative here.
A negative divided by a negative makes it a positive.
So that's going to equal to 5.5. Alright, I think that is it for us. If you have any questions, just let us know, and we're more than happy to help you all out. Thanks, guys.